In this video, let's discuss the cross-elasticity of demand for complements. Recall from the previous video that we argued the concept of cross-elasticity of demand in the case for substitutes. So we saw that when the cross-elasticity of demand is positive, it means that this is applicable for related goods that happen to be substitutes. So for instance, if the price of apple in that case goes up, then the quantity demanded for bananas would go up as well. Why? Because as apples become more expensive, we demand less apples and switch more to bananas. That's why the cross-elasticity of demand had a positive value. Now, in this case, I want to argue the same reasoning, however, applicable to complementary products, since, as I said, the relation between the products could be that they are either substitutes or complements, and that's what we're going to discuss right now. So for instance, I will take an example made up by myself based on running shoes and running pants. Let's consider, for the sake of the example, that these two products are complementary, and it makes somewhat sense because when you want to go running, you need shoes and you need pants that usually are designed for running. So according to this example, let's suppose that these are the following changes on the market. Now, the running shoes, let's say that it changes the price, okay, from $100 per pair to $150, meaning that we have the price initial of $100. Over here I'm gonna write this data, okay? So let me do that. Price initial is going to be $100 per pair, whereas the final price is going to be $150 per pair. So basically what I'm trying to prove right now is what happens on the market when the price of the shoes, the running shoes, increases. Now, first of all, let's see what is going to be the percentage change in the price over here. Well, the percentage change in the price is going to be price final minus price initial over the price initial. So that's going to be 150 minus 100 divided by 100. That happens to be 50 over 100, and that's equal to 1 over 2 or 50%. However, for the sake of simpler algebra in the upcoming few steps, I will keep it as a fraction. Now, suppose that the quantity demanded for pants is affected as well. And how can it be affected? Well, think about it logically now. If the running shoes become more expensive, people would normally buy less running shoes. And because they buy less running shoes, they would also buy less running pants, since they are complementary. So if they need less shoes, they would technically need less pants as well. Hope this makes sense. Now, for the sake of the example, let's say that the quantity initial for running pants was 1200 units, okay, 1200 pairs of running pants. And the final quantity, it decreased to just 1000 pairs. So percentage wise, the change in quantity demanded for running pants would be the quantity final minus the quantity initial divided by the quantity initial, and that would be equal to 1000 minus 1200 divided by 1200, and that would be equal to minus 200 over 1200, and that would be minus 1 over 6. Now let me zoom out to get more space and continue with some algebra. So with these two values in mind, the percentage change in quantity demanded and the percentage change in price, we can compute our cross elasticity of demand. So I'll do it over here, okay? As a result of everything, the cross elasticity of demand is going to be the percentage change in quantity demanded for running pants divided by the percentage change in the price of running shoes, and that would be minus 1 over 6 divided by 1 over 2, which happens to be minus 1 over 6 times 2 over 1, and that's equal to minus 2 over 6, which is equal to minus 1 over 3. So in other words, what we are saying right now is that when the price of running pants, let me say that again, when the price of running shoes increases by 1%, okay, when the price of running shoes increases by 1%, then the quantity demanded of running pants decreases by 1 over 3 or 0.33%. The difference that I'm trying to prove in this video is the sign of the cross elasticity of demand. The sign is showing the direction of change, and as we can see, the percentage change in quantity demanded decreases, so that's why they are complementary. Because as the price of running shoes goes up, quantity demanded for running shoes goes down, and therefore the quantity demanded for running pants goes down as well because they're complementary. And the magnitude of the elasticity, so how large it is, whether it's inelastic or elastic, is gonna depend on how close how closely related these complements are. 1/3 is less than 1, right? So that is the criteria for having an inelastic demand. Inelastic demand. So we have an inelastic cross elasticity of demand over here. Why is that the case? Why is it inelastic? Because even though the running shoes increase in price, people do not react that much in their consumption of running pants, since the running pants, even though they're complementary with running shoes, they are not that strongly complementary, because the running pants can be used also for just maybe going to the gym or just going outside in a casual sporty style. So it's not like if you don't have running shoes you would never wear running pants. You can still wear running pants and you would still buy them to the extent that you want to buy them, even though you have less running shoes. So there would be an effect on the market, there would be an effect on the quantity demanded of these running pants, but it would not be that large, okay? That's the criteria of an inelastic demand. And with the same reasoning, if we would have a cross elasticity of demand of minus 3.1, for instance, well, in that case we would argue that we have an elastic cross elasticity of demand. And in that case this would be because the complementary extent between the two products is very high, so the products are strong complements to each other. Hope this all makes sense, and we are done.